Characteristic of cold cathode diode. The volt ampere characteristic of a cold cathode diode is shown in figure. This figure. At low anode cathode voltage, the tube current is very small. It's like 1 ampere. This 1 ampere current flowing, and it's due to ionization of gas modules by the natural source. This space of conduction up to voltage B is known transient discharge and is non self-maintained discharge because it requires an external source to cause ionization. At some critical voltage such as B, like B is critical terminal, and critical voltage the tube fires and the voltage are across the tube drops B to C. It's the normal 1 ampere small current 1 ampere, and it's going to be the B point, and it's the critical moment and critical situation, and a B is going to C terminal. So we look that, and it remains constant regardless of plate current. This is start of second conduction and known as glow discharge. Look, this glow discharge, and it's a glow tube in this region C to D and D to E. And then voltage across the tube remains constant even if the plate current is increased. Firstly, the first condition, the low ampere going to this area A ampere, and 1 ampere current increases, and then it's like going to be B point, and this condition is critical, and the upcoming C condition, and then D, and then E condition. And in this region C to D, voltage across the tube remain constant even the plate current increase. Its voltage in transient discharge. After the glow discharge, the voltage across the tube no longer remain constant. Now, if the supply voltage is raised, not only will circuit current increase, but the voltage across the tube will start to rise again. The stage of condition D to E is known as abnormal glow. I again say after the glow discharge, the voltage in this voltage its voltage it's will be not only circuit current increase, but the across the tube will start rise again. The stage conduction D to E, it's going D to E, and is known as the abnormal glow. The outstanding characteristic of a cold cathode gas diode to maintain or glow tube, it's maintain all the over currently glow tube or maintain constant voltage across in the glow discharge region. Its renders is suitable for many industrial and control application. A few of such applications are mentioned. A glow tube maintains constant voltage across it in the glow discharge region. This characteristic permits it to be used as a voltage regulating tube. This figure, voltage regulating tube. This voltage regulating tube, and this voltage are increasing and the region of resistor, and it's going to voltage region. It's the simple circuit commonly and used to maintain constant voltage. It's maintain the constant voltage across the load. This load is incoming if the load current incoming, and this load is supply. It's our load. This current increases it, and the circuit is commonly used, and this type going for the load across the load. The glow tube, VR tube, its nickname VR tube, is connected in parallel with the load. It's connected. It's we'll look this area. It's a parallel circuit with the load RL, across which constant voltage is desired. So long as tube operates in the glow discharge region, it will maintain constant voltage across the load, and its voltage 150 volt. We show it. It's 150 volt. Look, it's 150 volt. As a particularly indicator, as the cathode surrounded by characteristics glow, therefore direct voltage, and as electronic switch which close at ionization potential, permitting a large current to the flow current. Large current to the flow current, and its voltage is 150. And we'll look again our hot cathode gas diode. A hot cathode gas diode is frequently used as a rectifier for moderate voltage because of high efficiency and better regulation. A hot cathode gas diode consists of an oxide coated cathode and metallic anode enclosed in a glass involved this type area. It's containing some intergas under reduced pressure. Its current incoming, its voltage and its resistance pressure, and the supply of DC. And its operation shows the circuit can be used to investigate the operation hot gas cathode. When the cathode is heated, a large number, when the gas is heated, supply in incoming, and it's the heated time, the large number of electrons are emitted. As low anode cathode voltage, the tube conducts very small current. Under such condition, the gas is ionized. The gas is total ionized. Supply and incoming, and this heated and ionized. So the tube acts similar to vacuum diode. The voltage across tube increases with plate current. The action contains until anode cathode voltage become equal to the ionization, and see we look that characteristic curves. An ionization potential of gas, once the potential is reached, the gas begins to ionize, creating free electrons and positive ionization. This further reduces the tube resistance. As a result, increase the plate current is offset by decrease in tube resistance, and the voltage across tube remain constant. Therefore, in a hot cathode gas diode, not only the internal drop within tube is a small, but also it remains constant. For this reason, a gas diode has better efficiency and regulation than a vacuum diode when used for a rectifier. And our characteristic curve is developing, and the point of A is pointing of A point. It's right A, and extra drops voltage and rise sharply. Its voltage drop across the tube constant, and series resistance R, and this any EB above point, higher plate current IB, and large drop across voltage EB across the tube remains constantly. It's IB plate current. And the developing remains constant.